All right, so we're going to go over section 4.6, which is all about polynomial and rational inequalities. So inequalities means it's not an equation. We don't have an equal sign. Instead of having something like ax squared plus bx plus c equals 0, right, something like that, we're going to have a greater than or equal to, less than, equal to, or maybe a greater than or a less than, okay? So what we're doing is, before, what we've done this whole section is find the zeros, right? So we can graph these higher order functions. So what we're looking at now is not necessarily finding the zeros. We're not saying where are the y values equal to 0, where are the x-intercepts. We're asking where is this function greater than 0, meaning where is it above the x-axis or where is it below the x-axis. So I don't necessarily need to graph the whole thing and see how high up or how high down the loops go. I just want to know, are the loops of this function above the x-axis or are they below? So what we're going to do is find all the x-intercepts so we know where they touch or cross. And then we're just going to test the intervals, kind of like we did when we were graphing, except instead of getting an actual solution point, we're just going to see if they're positive or if they're negative, because then we'll be able to tell if that interval that contains that point is a solution or not, okay? So a couple of things that we need to know strategy-wise. We want to make sure that we get it into standard form, which is like this. We want everything on one side so that after our symbol, all we see is a 0, okay? If we happen to be dealing with one that's a fraction or a rational expression, we want to make sure we get it into one fraction term or one rational expression, okay? So you may have to get a common denominator at that point, and I'll show you one like that, okay? Then we want to find the zeros. So in this case, we would just do some product or quadratic formula or something to factor this and find out what our actual zeros are. Okay, if we're dealing with a rational expression, we're going to find both the zeros of the numerator and the denominator. Okay, and then, like I said before, we're just going to test the intervals to determine if they're positive or negative. And then we shade our solution graph accordingly based on what our symbol is asking for. So if we see a less than or equal to, okay, these are less than because we see the little point first. That means we want the negative intervals because we're asking where is it less than 0 means it's below the x-axis, right? If we're looking for a greater than or a greater than or a greater than or equal to symbol, then we're looking for the positive intervals, okay, or where the function is above the x-axis. All right, and then the only other thing to note is if we have the equal to bar under our symbol, that means that we are talking about inclusive values, meaning we use brackets to include those zeros, okay? If we are dealing with strict inequalities, then we use parentheses. Parentheses means that those 0 values cannot be included, okay? So let's just go ahead and jump into one so that you can see the process here, all right? So on this first one, notice everything's already on one side. It's already isolated with the 0 on the right-hand side. So just looking at my symbol right here, it's a greater than. So greater than tells me that we want the positive intervals, okay? And because it has that equal to bar, that tells me that we're going to use brackets, okay? So before we start figuring out our solution, we first need to know our actual zeros. Where are our x-intercepts? Okay, so we just set each of these equal to 0. So this means that x equals 0, x minus 4 equals 0, or x minus 2 equals 0, or 2x plus 5 equals 0. Sorry, I'm kind of writing it all over the place. I just don't want to run into what I just wrote. So this one's already solved. X equals 0, check. And then here we have to move the 4 over. So this gives us x equals 4. So that's an x-intercept. We move this one over. We get x equals 2. So that's an x-intercept. And then this one we need to move the 5 over. So 2x equals negative 5. And then divide off the 2. So we get x equals negative 5 halves. So I have 1, 2, 3, 4 different x-intercepts that may either touch or cross, right? So those are all points where it may change from positive to negative or negative to positive. So what I want to do is put them, I'm just going to pretend this is like my x-axis, and I'm going to put all of those zeros on my axis here. So the first one, the smallest one, is -5/2, right? And then the next one is 0. And then the next one is 2. And then I have 4. Okay, and I don't care if they're equally spaced out or if you try to scale it, whatever. I don't care. I just want to know that those numbers are on the number line. So what I'm going to do is I'm going to try to determine, is the function in this interval above the x-axis or below? And are the function values between these two zeros above or below the x-axis? And so on and so forth. So I'm going to pick a test point within each interval. Okay, so I'm going to go ahead and write out the intervals. So the first interval I have, this one right here, is going to be from -infinity up to my first 0, which is -5/2. And then we're using a bracket to show that we're going to include the zeros. So I'm going to use a bracket there. And then again, my next interval is going to be from -5/2 over to 0. And again, I'm going to use a bracket. And then a bracket from 0 to 2. And then a bracket from 2 to 4. And then my last interval is from 4 to infinity. Okay, so these are all the intervals that I need a test point for. So kind of like we did in section 4.2 and 4.4, we're just going to create, I'm going to write this as a chart because I feel like it's a little bit easier to see. Okay, so I want to pick an x value and I want to know the sign of the y value. Okay, because I don't actually care what the y value is. I just want to know if it's above the x-axis or if it's a negative, if it's below the x-axis. Okay, so I'm going to pick something that's smaller than -5/2. Well, -5/2 is -2.5. So something smaller than -2.5, I'm just going to pick -3. Okay, something between -2.5 and 0, I'm going to pick -1. Something between 0 and 2, I'm going to pick 1. And then something between 2 and 4, I'll pick 3. Something bigger than 4, I'll pick 5. Okay, so these are the numbers that I want to plug into my function and see if I get a positive or a negative. So I'm just going to rewrite this function down here. So I have x times x minus 4 times x minus 2 times 2x plus 5. So I'm going to plug these in. So when I plug in a -3, and like I said, I'm not actually going to get a value, so I'm just going to use signs to show me if they're positive or negative. So when I plug in a -3 for x, that's going to give me a negative. When I plug in -3 into this next quantity, -3 minus 4, that's going to give me a negative. -3 in for this next quantity, -3 minus 2 is also going to give me a negative. And then when I plug -3 into this last quantity, -3 times 2 is -6, plus 5 is going to give me a negative. Okay, so if I plug -3 into all of these and they all end up negative, when I multiply 4 negatives together, that's going to give me a positive interval, right? And notice here, I want positive intervals. So that means that this interval is going to be part of my solution. Okay. Then I want to do the same thing with -1. -1 in for x is going to be negative. -1 in for x here, -1 minus 4, it's going to be negative. -1 in for x here, -1 minus 2 is negative. And -1 into this quantity, 2 times -1 is -2, plus 5 is going to be positive, right? So when I multiply and I get 3 negatives and a positive, that makes this a negative interval, which I don't want negatives because my sign is a greater than. So this is not going to be part of my solution set. Okay, so I move on to my next one, which is +1. +1 in for x is positive. +1 minus 4 is negative. +1 minus 2 is negative. And +1 times 2 is 2, plus 5 is still positive. So 2 negatives and 2 positives all multiplied together is going to give me a positive interval, which again is what I want for my solution. Okay, and then I keep going. I'm going to plug in 5 and 3. So when I plug in 3, I'm going to get a positive, a negative, a positive, and a positive. So 3 positives and a negative make this a negative interval, right? And then when I plug in 5, 5 is going to give me a positive, a positive, a positive, and a positive. So that's going to give me a positive interval. Okay, so now that I know the solution intervals, I want to go ahead and graph them and then state interval notation. Okay, so this tells me that we're positive all in this interval. We're using brackets. And then we're positive between 0 and 2, again with brackets. And then we're positive on any values larger than 4. So that's how I would graph my solution. And then my actual solution written in interval notation would be just these intervals that I checked, right? And we want to put union symbols between them. So from negative infinity to negative 5/2 with a bracket is going to be positive, or my next interval, which was 0 to 2, or over here from 4 to infinity. Okay, so this is going to be my solution on this one. Okay, so not too bad, right? All we do is find the x-intercepts, and then we're just testing points in between all those x-intercepts to see if the function values are above the x-axis, if they're positive, or if they're below the x-axis and they're negative. And then based on our symbol, that tells us whether or not we want positive intervals or negative intervals as our answer. Okay, so that's pretty much the gist of what the whole section is about. Now I just want to go through some more examples where, unlike this one that was factored for us, we may have to factor it ourselves. And then I also want to show you some examples of rational inequalities, meaning we have fractions. Okay, so let's go ahead and look at another one. On the back page, we have x squared is less than negative x plus 90. So when I start factoring this, I can't just do it as it is. I need it to be written in standard form, which means I want everything on one side so that I just have a 0 on the right-hand side. So I'm going to go ahead and move this negative x and the positive 90 over to the other side. Now when I move them, they're going to change signs. So I'm going to have x squared plus x minus 90 is less than 0. Okay, now that it's all isolated on one side, I can go ahead and look at this symbol. This symbol is a less than, which means that I'm going to want the negative intervals here. Okay, the negative intervals. And if I want the negatives and there's no equal to bar on my symbol, that means I'm going to be using parentheses. Okay, all right. So now that I've determined what type of intervals I want and what type of symbols I'm using, I'm no longer going to consider this a less than. I'm going to solve this just as if it was an equal to. So I'm going to do sum product so that I can get this factored and find my zeros. So when I do my sum product chart, my sum is going to be a positive 1 and my product is going to be a negative 90. So I need something that multiplies to negative 90 that combines to 1, which would have to be 10 and negative 9, right? And because my leading coefficient is a 1, I can use my shortcut. So that tells me that this factors into x plus 10 times x minus 9. And remember, we're solving this as if it was an equal to 0 because we're trying to find those x-intercepts or the zeros of this function. Okay, so when I solve this one, I'm going to get x equals negative 10. When I solve this one, I'm going to get x equals 9. So those are the two x-intercepts that I want to put on here and test in between. So I'm going to put negative 10 on my graph, and I'm going to put a positive 9 on my graph. Okay, and then I'm just going to write out the intervals in between using parentheses. So this first interval would be from negative infinity up to negative 10, then negative 10 to 9, and then 9 to infinity. Okay, and I just want to pick test points for each one. So here I'm going to pick my x test point, and then here I want to figure out what the sign of my y is going to be. Okay, so when I well, let's pick our test point. Something smaller than negative 10 would be negative 11. Something between a negative and a positive, I'm going to pick 0. Something larger than 9, I'm going to pick 10. Okay. So now that we have our test values, there's two places that we could plug these in potentially. And it doesn't matter to me which one you do, but it's very important that you plug it in one of these two places. The first place that you could plug it in is your function once you get everything on one side. So you could plug it in right here to your x squared plus x minus 90 and see if this ends up positive or negative. Or you can plug it into the factored version, okay? I prefer to plug it into the factored version. So that's what I'm going to write down here. X plus 10 and x minus 9, because I think it's easy to see what the signs are going to be. So if I plug in a negative 11 plus 10 in this first quantity is going to give me a negative, and negative 11 minus 9 is going to give me a negative. And a negative times a negative is a positive interval. And notice we don't want positive intervals, we want negative intervals because we had a less than. Okay, then we check 0. If I plug 0 in, 0 plus 10 is positive, 0 minus 9 is negative, and a positive times a negative gives us a negative interval, which we do want, right? That's what we're looking for. And then we plug in a positive 10, 10 plus 10 is positive, 10 minus 9 is positive, and a positive times a positive is a positive interval. So the only solution interval we got was here between negative 10 and 9, and we're using parentheses. So our solution interval notation would be from negative 10 to 9. Okay? Always pay attention to this symbol, because you could have this exact same problem, and if that symbol was pointed the other direction, or if it had an equal to bar, it could be different intervals or different symbols on your answers. Okay? All right, so that's pretty much the gist of it. Now I want to show you two examples where we have a rational expression. Okay, so looking at this next one, we have 2x squared minus 18x all over x squared minus 2x plus 1. So notice it's already all on one side. The zero's isolated on this side, so we can go ahead and look straight at our symbol, see that it's a less than. That means we want the negative intervals, okay? And because it's a less than or equal to, it has an equal to bar, we're going to use brackets, okay? So now because this is rational, we have to find the zeros from the top and the zeros from the bottom, because those are both areas that could cause our function to change from positive to negative. Not necessarily, but it could. So let's go ahead and look at those individually. So if we look at just the top, we have 2x squared minus 18x, and again, I'm just going to look at it equal to 0 because we're looking for zeros. Once I determine what type of intervals I want and my symbol, I no longer need to think about this as an inequality. I'm going to solve it like it's an equation. Okay? So here I can take out a greatest common factor, which is 2x, and I'll be left with x minus 9. And then I just set each of these equal to 0 and solve. So if I set 2x equal to 0, I'm going to get x equals 0. If I set x minus 9 equal to 0, I'm going to get x equals 9. Okay, now these both came from the top, and my symbol tells me to use brackets. So I'm going to write brackets next to both of these. Okay, then I look at the bottom, or my denominator, which is x squared minus 2x plus 1, and I'm going to set it equal to 0. Now this one has 3 terms and an x squared, so I'm going to try sum product. My sum is a negative 2, and my product is a positive 1. So I need something that multiplies to a positive 1 that I can combine to a negative 2, which would have to be negative 1 and negative 1. And again, I can use my shortcut factoring method because my leading coefficient is a 1. So this factors into x minus 1 times x minus 1, or I could write this as x minus 1 squared, right? Because I don't really need to solve it twice. When I set x minus 1 equal to 0, I get x equals positive 1. Now, here's something that changes a little bit when we're dealing with rational expressions. Because this is a 0 from the denominator, what that means is if I took 1 and I plugged it into this, I would get a 0 in the denominator. And it's not possible to work with something when there's a 0 in the denominator because it's undefined, right? So even though this little symbol here tells me to include my zeros, which I did on the top, I can never, 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 never include zeros that make the denominator 0. So any zeros you get from the bottom, whether you get 1, 2, 3, 4, 10, right? Whatever makes the denominator 0, we have to use parentheses on, okay? So once we've identified all the zeros from both the top and the bottom, we're going to go ahead and put them on our graph over here. So we have 0, we have 1, and we have 9. So we're going to write out all our intervals. So we have from -infinity to 0. Now 0 came from the top, so we can use a bracket on it. And then again, a bracket at 0 over to 1. 1 came from the denominator, so we have to use a parenthesis on 1. And then a parenthesis at 1 over to 9. 9 came from the top, so it's okay to use a bracket on. And then another bracket at 9 out to infinity. Okay? So now that we have our intervals, we want to go ahead and pick test points so that we can see if they are above or below the x-axis, right? So for this interval, I'm going to pick a -1. Something between 0 and 1, I'm going to pick a half. Something between 1 and 9, I'm going to pick 5. And something bigger than 9, I'll pick 12, right? Doesn't really matter. As long as the number you pick is in that interval, you'll get the right sign, okay? And this is going to be the sign of our y value. Now, where am I plugging these into? I could go ahead and plug it into this entire rational expression as it looks because it's already isolated. But again, I like to plug it into the factored version. So notice when we factored the top, we ended up with 2x times x minus 9. And on bottom, we ended up with 2 copies of the quantity x minus 1. So I'm just going to leave it as x minus 1 squared. Okay, so when we plug in our values, we plug in a -1. -1 times 2 is going to be negative, right? -1 minus 9 is going to be negative. And then on bottom, -1 minus 1 is -2. But then when I square it, it becomes positive, right? So 2 negatives and a positive are going to make this a positive interval, right? And then I look at 1/2. When I do 1/2 times 2, that's positive. When I do 1/2 minus 9, that's negative. And on bottom, 1/2 minus 1 is negative, but then I square it, so that becomes positive. So really it doesn't matter what we plug in down here. Because this is a squared quantity, we should always get a positive underneath, right? So here we have 2 positives and a negative. So this is going to be a negative interval. And then we try 5. 5 times 2 is going to be positive. 5 minus 9 is going to be negative. And on bottom, we end up with a positive because it's squared, right? So 2 positives and a negative give us another negative interval. And then on our last one, we plug in 12. 2 times 12 is positive. 12 minus 9 is positive. And then we know whatever we get here when we square it is going to end up positive. So 3 positives make this a positive interval. So I go back and look at what type of intervals I want. I want negatives, which is this interval and this interval, right? So I want from 0 to 1 and from 1 to 9, and then I just need to check my symbols. 0 is included because it came from the top, so I have a bracket. 9 was also included, but notice 1 isn't. So even though it kind of looks like I could just shade right across, because my 1 came from the denominator and the denominator does not include zeros, we have to go ahead and put those parentheses in there to show that these are 2 separate intervals and that 1 is not included. So for our interval notation, it would be from 0 to 1 and then from 1 to 9. And we can just leave it like that. Okay. All right, let me show you one more, and then I'll have y'all try some. So on this one, I want it basically to look like this one we just did. The one we just did, notice I had one fraction on one side and 0 on the other. So I want to do the same thing here. So I'm going to move this 16 over x plus 3 over to the other side. So I have my 4x that was already there. And when I move 16 over x plus 3, this is a positive term. So to move it, I'm going to have to subtract 16 over x plus 3. And that's greater than or equal to 0. So now I have everything on one side, so I can go ahead and look at this symbol. The symbol is a greater than or equal to. That means that I want positive intervals, right? And because it has the equal to bar, I'm going to use brackets. Okay. All right, now I can't start finding zeros of top and bottom and all that until I get this looking like one fraction. So I'm going to go ahead and write 4x as a fraction by putting it over 1. And in order to write these together, I need them to have the same denominator. And right now, my common denominator would have to be this x plus 3. So if I want to write this term with x plus 3, I'm going to have to multiply by x plus 3 on top and bottom. Okay. So when I multiply it on top, I'm going to go ahead and distribute this 4x. I would get 4x squared plus 12x all over x plus 3 minus 16 all over x plus 3, right? And now that they have the same denominator, I can go ahead and just subtract across on the top. So this gives me 4x squared plus 12x minus 16 all over x plus 3. So now I need to find my zeros from the top and my zeros from the bottom, right? And we can write it separately. This one's actually pretty easy to do, so I'm just going to keep simplifying it the way it looks. On top, I notice every single term is divisible by 4. So I'm going to go ahead and take a 4 out. That's going to leave me with x squared plus 3x minus 4. And that's all over x plus 3. And then I want to try to factor this so I can easily see what the zeros are. So in order to factor this, I'm going to use my sum product chart. My sum is a 3, and my product is a negative 4. So I need something that I can multiply to get negative 4, that I can combine to get 3, positive 3, right? Which would have to be 4 and negative 1, and I can use my shortcut, right? Yay, because my leading coefficient is now a 1 since I took that 4 off. So that means this is going to factor into x plus 4 and x minus 1. So I have my greatest common factor out there of 4, and then this factors into x plus 4 times x minus 1, and on bottom I have an x plus 3. Okay, so now I just need to find my zeros from the top and the bottom. So on top, if I don't need to set this 4 equal to 0, right? Because it doesn't have a variable, so that one doesn't matter. When I set x plus 4 equal to 0 and solve, that's going to give me x equals negative 4. And when I set x minus 1 equal to 0, that's going to give me x equals positive 1. And since both of these came from the top, I can use a bracket on both of them. Okay? And then I want to look at the bottom. The bottom, I just have the factor x plus 3. If I set that equal to 0 and solve, I'm going to get x equals negative 3. And because it came from the denominator, and we can never allow numbers that cause the denominator to be 0, we have to use parentheses on this one to show it's not included. Okay, so these are my 3 zeros that I need to put on my graph. So the smallest one is negative 4, and then negative 3, and then 1. Right? So now I want to go ahead and test these intervals. So I'm going to test from negative infinity to negative 4. Negative 4 came from the top, so I can use a bracket on it. Then again, negative 4 over to negative 3, which came from the denominator, so I have to use a parenthesis. Then a parenthesis at negative 3 over to 1, which came from the top, so I can use a bracket on 1. And then a bracket on 1 on out to infinity. I'm going to go ahead and draw my little chart in. So I'm going to pick an x value and then figure out what the sign of the y values are for that interval. So something smaller than -4, I'm going to pick -5. Something between -3 and -4 would be -3.5, right? Something between -3 and 1, I'm going to pick 0, and something bigger than 1, I'm going to pick 2. So when I plug these in, I want to make sure I plug them into this factored version, right? You could plug them in over here once we got everything on one side, or even here, but I think it's easier to just plug them into the factored version. So notice, even though this 4 doesn't have a variable, so it's not going to change signs, sometimes we do have a greatest common factor of a negative. So I'm still going to include that 4 as a positive factor. So we have the 4 that's already there, which is positive. If I plug a -5 into my second quantity, -5 plus 4 is negative, and -5 minus 1 in the third quantity is going to be negative. And on bottom, -5 minus 3 is going to be negative. So I have 3 negatives and a positive, which makes this a negative interval. Okay. Then I want to do the same thing for my next number. So -3.5, notice I already have this positive 4 out front. -3.5 plus 4 is going to be positive. -3.5 minus 1 is negative. And on bottom, -3.5 plus 3 is going to stay negative. So 2 positives and 2 negatives make this a positive interval. Then I'm going to check 0. Notice again, I still have this positive 4 out front. When I plug a 0 in, I get a positive. When I plug a 0 in here, I get a negative. And a 0 in the denominator leaves me with a positive. So 3 positives and a negative make this a negative interval. Okay. Then I want to do the same thing with 2. I have a positive 4 that's already there. And then 2 plus 4 is positive. 2 minus 1 is positive, and on bottom 2 plus 3 is positive. So all positives multiply to give me a positive interval. Okay, so now that I know the signs of all my intervals, I go back to see what I wanted. I wanted the positive intervals, so that's my second and fourth ones. So between -4 and -3, and things larger than 1. And then I can just copy the symbols that I had already written down. So bracket at -4, parenthesis at -3, bracket at 1. And then I just need to write my solution set, which would be from -4 to -3, and then from 1 to infinity. Make sure you have the correct symbols for your numbers. Okay? All right, so there are, I believe, 3. Yes, there are 3 for y'all to try, and this concludes Unit 4. So make sure you get the My Math Lab assignment done. And when you're working it out, I encourage you to show all of this work, because when I give you a problem like this on the test, if all you have is the function written and the solution written, you're going to lose credit. Okay, I want to see that you have the intervals, that you picked a test point, that you showed me what the sign is, and then chose your solution accordingly. Okay. Also, at the end of the notes packet, as always, there's the review for you to work on, which are just all the practice problems throughout the unit. If you have any questions, let me know. Otherwise, get ready for your test. All right, go ahead and pause it, work on the practice problems, and then we'll go over them. Okay, so on the first practice problem, you should have moved the 45 over and then factored into x plus 9 and x minus 5. So your zeros are -9 and 5. And we want the positives because it's greater than, and we're going to use parentheses. So we should be testing from -infinity to -9, which should be a positive interval, from -9 to 5, which ends up being a negative interval, and then from 5 to infinity, which ends up being positive. Because we wanted positives, we end up with this first interval and this last interval. Okay, make sure you're graphing your answers, and then we'll go ahead and look at number 2. Okay. If you need more time, you can always pause the video. So on this one, it's already all on one side ready for us. So all we have to do is factor top and bottom. The top's already factored, so we just solve it, and it should give us a positive 1/2. On bottom, we do sum product, and the 2 zeros we should get from it are 5 and -1. Now, our symbol tells us we want positive intervals with brackets. So brackets we can use on top. Brackets we never use on bottom. On bottom we always use parentheses. Okay, so we should have the interval from negative infinity to 1, 1 to a half, 1/2 to 5, and 5 to infinity. On 1 and 5, we have to use parentheses because they came from the bottom. Okay, only the 1/2 can use brackets. Okay, and then we test those accordingly. Now, when you test them, you can plug them into this original the way it looks right here, or you can plug it into the factored version. So that's what I did. I wrote the factored version up here. The top was 2x minus 1, and then I put the two quantities that I got when I factored the bottom down here in the denominator. So I'm plugging it into this when I test my intervals. Okay? Because we want the positive intervals, we should be getting the second and fourth intervals here and shading those intervals on our graph. Make sure your symbols are correct. If not, go ahead and pause it, go through it, check yourself. Okay. All right. And then on the third one, same idea. We don't determine what kind of intervals and all that we want until we get this thing isolated. So we go ahead and move our 9 over x plus 2 to the other side by subtracting. And then we need to get a common denominator. So we need to multiply the first term on top and bottom by x plus 2. And then whenever we distribute that 3x into the quantity, we get 3x squared plus 6. And then we can go ahead and subtract the 9 because their denominators are the same. Okay. From here, you can either keep working it like I did in one fraction, or you can break it up like it's shown here. Okay. Either way, we take a greatest common factor of 3 out, and then we should be able to use our sum product method to factor this into x plus 3 and x minus 1. That gives us a -3 and a 1. And on bottom, we should end up with a -2. We're going to be using parentheses on everything, even top and bottom, because this was a strict inequality with no equal to bar. Okay. Since it's a less than, we want the negative intervals. So negative infinity to -3, -3 to 2, -2 to 1, and 1 to infinity. We pick our test points and we plug it into the factored version, which I have written down here. So from the top, we had our greatest common factor, and then it factored into x plus 3 and x minus 1. On bottom, we just had the quantity x plus 2. So this is what I'm plugging my numbers into. You may also plug it into this part or even this part, but just make sure you don't plug it in to any part unless it's all on one side and zeros by itself on the right-hand side. Okay. All right. So since we wanted the negative intervals, it should have been our first and third intervals and parentheses on everything. Okay. All right. So that is the end of this section. You should now be able to finish that assignment. If you have any questions, please let me know.